age. Nevertheless, a crust consisting chiefly of the comparatively lighter granite is gradually forming. The stage is being set for a planet which can someday support life. The primitive planetary atmosphere is slowly evolving, now containing some water vapor, carbon monoxide, carbon dioxide, and hydrogen chloride, but there is little or no free nitrogen or free oxygen. The atmosphere of a world in the volcanic age presents a queer spectacle. In addition to the gases enumerated, it is heavily charged with numerous volcanic gases and, as the air belt matures, with the combustion products of the heavy meteoric showers which are constantly hurtling in upon the planetary surface. Such meteoric combustion keeps the atmospheric oxygen very nearly exhausted, and the rate of meteoric bombardment is still tremendous. Presently the atmosphere became more settled and cooled sufficiently to start precipitation of rain on the hot, rocky surface of the planet. For thousands of years Urantia was enveloped in one vast and continuous blanket of steam, and during these ages the sun never shone upon the Earth's surface. Much of the carbon of the atmosphere was abstracted to form the carbonates of the various metals which abounded in the superficial layers of the planet. Later on, much greater quantities of these carbon gases were consumed by the early and prolific plant life. Even in the later periods, the continuing lava flows and the incoming meteors kept the oxygen of the air almost completely used up. Even the early deposits of the soon-appearing primitive ocean contained no colored stones or shales, and for a long time after this ocean appeared, there was virtually no free oxygen in the atmosphere, and it did not appear in significant quantities until it was later generated by the seaweeds and other forms of vegetable life. The primitive planetary atmosphere of the volcanic age affords little protection against the collisional impacts of the meteoric swarms. Millions upon millions of meteors are able to penetrate such an air belt to smash against the planetary crust as solid bodies. But as time passes, fewer and fewer prove large enough to resist the ever-stronger friction shield of the oxygen-enriching atmosphere of the later eras. 8. Crustal stabilization, the age of earthquakes, the world ocean, and the first continent. 1 billion years ago is the date of the actual beginning of Urantia history. The planet had attained approximately its present size, and about this time it was placed upon the physical registries of Nebadon and given its name, Urantia. The atmosphere, together with incessant moisture precipitation, facilitated the cooling of the Earth's crust. Volcanic action early equalized internal heat pressure and crustal contraction, and as volcanoes rapidly decreased, earthquakes made their appearance as this epoch of crustal cooling and adjustment progressed. The real geologic history of Urantia begins with the cooling of the Earth's crust sufficiently to cause the formation of the first ocean. Water vapor condensation on the cooling surface of the Earth, once begun, continued until it was virtually complete. By the end of this period, the ocean was worldwide, covering the entire planet to an average depth of over 1 mile. The tides were then in play much as they are now observed, but this primitive ocean was not salty. It was practically a freshwater covering for the world. In those days, most of the chlorine was combined with various metals, but there was enough, in union with hydrogen, to render this water faintly acid. At the opening of this faraway era, Urantia should be envisaged as a water-bound planet. Later on, deeper and hence denser lava flows came out upon the bottom of the present Pacific Ocean, and this part of the water-covered surface became considerably depressed. The first continental landmass emerged from the world ocean in compensatory adjustment of the equilibrium of the gradually thickening Earth's crust. 950 million years ago, Urantia presents the picture of one great continent of land and one large body of water, the Pacific Ocean. Volcanoes are still widespread, and earthquakes are both frequent and severe. Meteors continue to bombard the Earth, but they are diminishing in both frequency and size. The atmosphere is clearing up, but the amount of carbon dioxide continues large. The Earth's crust is gradually stabilizing. It was at about this time that Urantia was assigned to the system of Satania for planetary administration, and was placed on the life registry of Norlatiadec. Then began the administrative recognition of the small and insignificant sphere, which was destined to be the planet whereon Michael would subsequently engage in the stupendous undertaking of mortal bestowal, would participate in those experiences which have since caused Urantia to become locally known as the World of the Cross. 900 million years ago witnessed the arrival on Urantia of the first Satania scouting party sent out from Jerusalem to examine the planet and make a report on its adaptation for a life experiment station. This commission consisted of 24 members, embracing life carriers, Lananandek's sons, Melchizedek's, Seraphim, and other orders of celestial life having to do with the early days of planetary organization and administration. After making a painstaking survey of the planet, this commission returned to Jerusalem and reported favorably to the system's sovereign, recommending that Urantia be placed on the Life Experiment Registry. Your world was accordingly registered on Jerusalem as a decimal planet, and the life carriers were notified that they would be granted permission to institute new patterns of mechanical, chemical, and electrical mobilizations at the time of their subsequent arrival, with life transplantation and implantation mandates. In due course, arrangements for the planetary occupation were completed by the Mixed Commission of 12 on Jerusalem and approved by the Planetary Commission of 70 on Urantia. These plans, proposed by the advisory councilors of the life carriers, were finally accepted on Salvington. Soon thereafter the Nebadon broadcasts carried the announcement that Urantia would become the stage whereon the life carriers would execute their 60th Satania experiment designed to amplify and improve the Satania type of the Nebadon life patterns. Shortly after Urantia was first recognized on the universe broadcast to all Nebadon, it was accorded full universe status. Soon thereafter it was registered in the records of the minor and the major sector headquarters planets of the superuniverse, and before this age was over, Urantia had found entry on the planetary life registry of Uversa. This entire age was characterized by frequent and violent storms. The early crust of the Earth was in a state of continual flux. Surface cooling alternated with immense lava flows. Nowhere can there be found on the surface of the world anything of this original planetary crust. It has all been mixed up too many times with extruding lavas of deep origins and admixed with subsequent deposits of the early worldwide ocean. Nowhere on the surface of the world will there be found more of the modified remnants of these ancient pre-ocean rocks than in northeastern Canada, around Hudson Bay. This extensive granite elevation is composed of stone belonging to the pre-oceanic ages. These rock layers have been heated, bent, twisted, upcrumpled, and again have they passed through these distorting metamorphic experiences. Throughout the oceanic ages, enormous layers of fossil-free stratified stone were deposited on this ancient ocean bottom. Limestone can form as a result of chemical precipitation. Not all of the older limestone was produced by marine life deposition. In none of these ancient rock formations will there be found evidences of life. They contain no fossils unless, by some chance, later deposits of the water ages have become mixed with these older pre-life layers. The Earth's early crust was highly unstable, but mountains were not in process of formation. The planet contracted under gravity pressure as it formed. Mountains are not the result of the collapse of the cooling crust of a contracting sphere. They appear later on as a result of the action of rain, gravity, and erosion. The continental landmass of this era increased until it covered almost 10% of the Earth's surface. Severe earthquakes did not begin until the continental mass of land emerged well above the water. When they once began, they increased in frequency and severity for ages. For millions upon millions of years earthquakes have diminished, but Urantia still has an average of 15 daily. 850 million years ago, the first real epoch of the stabilization of the Earth's crust began. Most of the heavier metals had settled down toward the center of the globe. The cooling crust had ceased to cave in on such an extensive scale as in former ages. There was established a better balance between the land extrusion and the heavier ocean bed. The flow